Hey everybody, so in this video, they ask us if cosine of theta is 4 over 5 and theta is in quadrant 4, then find the following. So what they want us to look for is these 6 trig ratios. So these are the 6 we've been working with for a long time. And then they also want us to find the reference angle and the measure of angle P. So let's see how we draw this. They tell us that cosine of theta is 4 over 5 and that theta is in quadrant 4. Okay, this is going to tell you where to draw your triangle. So if it's in quadrant 4, it should look something like this. So there's my right angle, and then the reference angle is always by the origin, every single time, no matter what. Now here they say cosine of theta is 4 over 5. Okay, we have to remember what cosine of theta is. So that ratio is the adjacent leg over the hypotenuse. So 4 is the adjacent leg. That's always going to be the leg that's touching the angle right here. The opposite leg never touches the reference angle. So here we have 4 and here we have 5 because that's my hypotenuse. Now, you should be familiar with what's called a 3, 4, 5 triangle. So this is going to be a value of 3. Now, if you're not sure how I did that quickly, that is fine. This is just a special case. Right triangle, you can easily do Pythagorean's theorem, and we can do that here. So if I said 4 squared plus this y value, right, this leg here, that's going to equal 5 squared. 4 squared here is going to be 16. Here we have 25, and I'll subtract 16 from both sides. So here I have y squared is equal to 9. And then now to get y by itself, because they're squaring it, I'll take the square root. So y here is going to be 3. Now, we talked about this in a prior video. Here's what you have to pay attention to. Theta is in quadrant 4. Look right here. In quadrant 4, the y values are negative. So we cannot forget that basic information from Algebra 1. Now that we have all 3 side values, we can find our trig ratios. So sine here is the opposite over the hypotenuse. So here, this is the opposite over hypotenuse. So remember, the opposite leg does not touch the reference angle. So here, this would be negative 3 over 5. So my ratio here should be negative 3 over 5. Now for the cosecant of theta. Cosecant is the reciprocal of sine. All you have to do here is flip this ratio. So here I can say this is negative 5 over 3. And you may say, but the 3 is negative, not the 5. Here, why did I make the 5 negative? It really doesn't matter which one is negative. The ratio is negative. The fraction itself is negative. A negative divided by a positive is a negative number. So here, this negative divided by this positive is a negative number. It doesn't matter where the negative goes, per se, when we're dealing with ratios. All right, cosine of theta, they gave us that in the problem, so we shouldn't get that wrong. That is 4 over 5. And then secant is just the reciprocal of this, so I can flip it, and that would be 5 over 4. Tangent is going to be the opposite over the adjacent. So remember, the opposite leg from the reference angle is the leg that it does not touch. Okay, so that's negative 3, and then the adjacent leg would be 4. So here I have negative 3 over 4, and then cotangent will be the reciprocal of this, and that will be negative 4 thirds. Now, here for the reference angle, they want us to find the value of theta itself here. Okay, so here's what we're going to have to do. We are going to have to use one of these 6 trig ratios. We are the most accustomed to working with these 3, so I would use one of these. Since we are going to have to do some math, let's pick the easiest one to work with. So why would we want to work with a negative ratio when we could work with a positive one? So here's what we got to know. They tell us that cosine of theta is 4 over 5. So here I have cosine, that's making a lot of noise. This is 4 over 5. Now, I want theta by itself. Well, how do I get rid of this cosine? Okay, you got to think cosine is a function. It's not really like an operation. You're not adding, subtracting, multiplying, or dividing. You're plugging something into this function and you're getting this value. So how can I reduce a function to 1? This is something we talked about in Algebra 2, and that is to multiply by the reciprocal. So here I'm going to say the inverse cosine times cosine of theta, and whatever I do to the left, I must do to the right. So this is now going to be the inverse cosine of 4 over 5. So here, the inverse times the function, this reduces to 1. So theta is left alone. So theta is the inverse cosine of 4 over 5. And for this, you are going to need a calculator. Okay? So because the reference angle here, they did not specifically tell us to work with radian. So let's work with degrees, because they're a little bit easier to work with as you're learning this. So we're going to make sure our calculator is in degrees, and we're going to do the inverse cosine of 4 over 5, and we're going to get 36.9. So here, the reference angle is 36.9 degrees. Now, they want the measure of angle P, okay? So right here, if cosine of theta is 4 over 5 and theta is in quadrant 4, then find the following. Measure P right here, I forgot to write it up here in one of the initial instructions, my bad. But we're going to call this right here point P. So remember, when we were talking about angles in standard position, you always have an initial side, right? And then this terminal side travels through the quadrant plane to get here. So I want to know, what is the measure of this angle? Okay, well, I have this 90 degrees, this 90 degrees, this 90 degrees, and then what is this value left right here? Well, we know this whole thing is 90, and now we know the value of this reference angle. It's 36.9. So I could say 90 minus 36.9, and that gives me 53.1. So here, this little bit right here is 53.1 degrees. Now I can say 270 plus 53.1. Now you say, Mr. Phillips, wasn't there an easier way? If I know this whole thing is a circle, couldn't I just say 360 minus the reference angle? Absolutely. Okay? Either one of those methods are going to give you the correct answer. So here, let's say we did that. 360 minus 36.9, we get 323.1, or I could say 270 plus 53.1, we get the same answer. So 323.1 degrees. And now, using a trig ratio and knowing where theta lies, we were able to find the value of all 6 trig ratios, the reference angle, and the measure of angle P. Okay, let's do another one. Okay, so here in this question, they tell us if tangent of theta is positive 4 over 7 and theta is in quadrant 1, then find the following. So here we have our quadrant plane. They tell us theta is in quadrant 1. Okay, so we know what that triangle should look like. If I drew a right triangle in quadrant 1, it would look something like this. The reference angle is always going to be by the origin. So they tell us tangent is 4 over 7. Okay, well, we know the ratio and the leg values of tangent. That is the opposite over the adjacent. There we go. All right, so the opposite of theta here is going to be 4, and the adjacent is going to be 7. Now we need to know the value of this hypotenuse in order to figure out the values of these trig ratios. So to do that, we're going to have to use Pythagorean's theorem. So here we have 7 squared plus 4 squared. This is going to be the value of c squared. Okay, so 7 squared gives us 49. 4 squared gives us 16. Here we have c squared. So now we're going to add these. So we have 40 and 10, that's 50, 59, 59 and 6 is 65. So here I have 65 is the value of c squared, and we want the value of c, not c squared. So this is the square root of 65 equals c. Okay? Now, for the purpose of this exercise, you do not have to simplify the square root, okay? One thing in higher level math, that's really going to depend on your professor. If you leave this class and you take AP Calculus, you do not have to simplify. Let's say this could be a simplified radical. On the AP exam, you would not have to. As long as this is numerically equivalent, you're going to get full credit. So I actually tell my students in higher level math, do not worry about simplifying. Do not worry about doing this. That takes time. Time is taken away from your test. Even your tests in my class right now are timed. Do not waste time. So leave the square root of 65 as is. So here we're going to say this is the square root of 65. And now we have values to write our trig ratios. So remember, we said sine was the opposite over the hypotenuse. So there's the opposite, there's the hypotenuse. I could say this is 4 over the square root of 65. Now, let's say you have a professor who is like, you have to rationalize this. Well, that's what your teacher says. I never want to see a square root in the denominator. Fine, whatever. We can do that here. So remember, to rationalize, we'd have to multiply by 1 because you can't change the value of this answer. And I'd have to multiply by the square root of 65 over the square root of 65. Okay? So I'm going to show that up here. And then the process would really be the same for all of these, but I'm not going to do it for every one. All right? So here, if I had 4 over the square root of 65, and I said rationalize, we're going to multiply by the number 1, which is going to write it in a way that's beneficial to us. And you say, how on earth is that beneficial? Because now, when I had the square root of one number times the square root of the same number, the square roots go away. So this could rationalize to be 4 root 65 all over 65. Now, this is only if your teacher wants you to do it. For my class, I do not care. Leave it like this. They're the same number. Okay? Now, cosecant, you flip. So here I'm going to say that is the square root of 65 over 4. And I want to go back to what I just said about these being the same number. Are they the same number? Yes. And, different people, depending on, their beliefs about this, they're going to get real finicky and they're going to say, well, actually, if this is an irrational number that goes forever and ever and ever, you can't say 4 divided by that. The calculator will tell you an error. Sure, here you're just putting the rational number in the numerator. Same thing that I did right here. That's all you're really doing. Okay, we'll call it the same. All right, moving on. Cosine. Cosine is the adjacent over the hypotenuse. So same thing, I have 7 over the square root of 65. If you got one of those, they want you to rationalize. Here, we can just say this is 7 root 65 all over 65. Now, secant, flip this. So I have the square root of 65 over 7. Tangent, they give us tangent, 4 over 7. All right, 4 over 7. Cotangent, flip it. So here I have 7 over 4. Now, they want us to find the reference angle. Okay, this is the reference angle. To use the reference angle, you're going to have to work with one of these trig ratios. Okay, these two do not look friendly and they don't look nice. Look at these numbers. I don't want to type all that on my calculator, especially when I could just type this. All right, so let's do that. So here, let's draw a little line. We have that the tangent of theta, we'll write it out like this, is 4 over 7. All right, that's the ratio. So we just talked about this in the last example. The only way you can eliminate this tangent, or that's not even the right way of saying it, reducing it to 1 is to multiply by its inverse. So here we're going to say that the inverse tangent times tangent of theta. I hate this marker already. So whatever we do to one side, we have to do to the other. So I have inverse tangent of 4 over 7. Okay, so the inverse times the function, that goes away. Well, not goes away, no, we shouldn't say that. It reduces to 1. There we go. So here, theta is the inverse tangent of 4 over 7. All right, you really want to get on your professor's nerve. I shouldn't say that. But technically, on the AP exam, you could leave it like this, right? That and the decimal are the same thing. So if they want the value of the reference angle, you could say the value of the reference angle is the inverse tangent of 4 over 7. If you wanted to, you don't have to. Just saying, same number. right? You're technically not wrong. So here, we're in degrees. Inverse tangent of 4 over 7, and that answer is 29.7. So here, 29.7 degrees, and they also want you to find the value of angle P. Now remember, angle P is this point at the top right here. Okay, and you also have to remember when you're in quadrant 1, the reference angle and the measure of the angle itself are the same. So this was actually a pretty easy question. So if the reference angle is 29.7, then the measure of angle P is also 29.7 degrees. Okay, we're going to do one more, and then that's going to be it for this video. Okay, so last example, they tell us that secant, one we have not used before, that ratio is -8/5, and then this angle, or excuse me, the reference angle is in quadrant 2. No, not the reference angle, theta. Theta is the angle. Come on. Okay, now, if the theta is in quadrant 2, then my triangle should look something like this, right? That's a terrible right triangle. It is what it is. Here, you know what? I just know some folks are just going to complain, and I'm like, oh my God. All right, there we go. Theta. No, the right angle. It's been one of them days. So here is the reference angle, and then, remember, you always have your initial side. This, right? This is the theta that's in quadrant 2, all right? So that makes this point P. Now they tell us secant of theta, or secant of this reference angle, let me get where you can see it, is -8/5. Okay, well, what is secant? Okay, secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, this is the hypotenuse over the adjacent. Okay, so here, don't put sine values yet. So this is 8 and this is 5. Here's the reason I told you not to put sine values yet. Which of these numbers is negative? The 8 or the 5? Oh, it doesn't matter. Nah. The ratio doesn't matter because a negative divided by a positive is negative. This ratio is negative. Here, it does matter because I'm trying to write the value of all 6 trig ratios. So which one's negative, the 8 or the 5? And that answer is the 5. And here's why. You're in quadrant 2. And in quadrant 2, in order to get to point P, you had to go left 5 and up some value. This hypotenuse represents the distance point P is from that origin. Okay? So distance is never negative. All right? So that's what the 5 is. You'll have to remember that and keep in mind when they tell you where that specific point is in the quadrant plane. Okay, now we want to find the value of this y. So we have -5 squared plus some y value squared, and this is equal to 8 squared. Okay, so -5 squared, that is going to give us 25 plus y squared. This is going to equal 64. I'm going to subtract 25 from both sides. I'm going to move a little bit so you can still see me, or excuse me, so you can see the writing. So y squared is equal to 64 minus 25, or 39. So I want y by itself. Y here is going to be the square root of 39. So I'm going to put that here. This is the square root of 39. Do not let the complexity of the number make you nervous, right? We have worked with these values like this before. Let me erase this so that we can write it neatly. Wow, Mr. Phillips, that's a lot neater. Whatever. All right, you can see the whole number now. You can see the square root sign. Okay, so sine. Sine is the opposite over the hypotenuse. The opposite of theta is the square root of 39. The hypotenuse is 8. So here we have the square root of 39 over 8. Cosecant will be the reciprocal of this. So that is going to be 8 over the square root of 39. If you rationalize, this would be running out of room here. 8 root 39 over 39. Yay! I wrote it all in the room. All right, cosecant. Cosecant is the adjacent over the hypotenuse. So that is going to be -5 over 8. Secant, they gave you -8 over 5. Tangent is the opposite over the adjacent. So the opposite over the adjacent would be the square root of 39 all over 5. This ratio is negative. Let's make a little space right in there. There we go. Now it looks more like a negative. All right, cotangent, flip that. So this is negative 5. I'm going to go ahead and rationalize. Root 39 all over 39. Okay, now, reference angle. How do I find the value of this? I'm going to have to use trig on one of these. Which one looks the easiest? Cosine. Don't work with these. Why would you do that to yourself? Okay, so I'm going to come over here, little dotted line. And we have cosine of theta is equal to negative 5 over 8. So now we kind of already know what we have to be doing. We're going to have to say that theta is equal to the inverse of negative 5 over 8. All right, so make sure you're in degrees for this because we've done all of these in degrees. So inverse cosine, this is negative 5 over 8, and that gives us 128.6. Now, hold up, let's think about that. Theta is 128 well, we'll round to the 10th and we'll say 7. Now, what is one rule we know about reference angles? Because here they want the reference angle. One of the rules you have to remember, reference angles cannot be larger than 90 degrees. Can this angle inside of a right triangle be obtuse? No, it cannot. Well, then what's 128.7? This angle right here. Mr. Phillips, why did that happen? There is a reason, and it has to deal with the function of inverse cosine. Now, we're not going to talk about that in this video. That's actually going to come later in this unit. But here, just know that for the purpose of finding reference angles, they cannot be larger than 90. If they are, if this value is larger than 90, then you're working predominantly with cosine, but you don't have to know that. What you need to know is if it's larger than 90, you found the measure of angle P, not the reference angle. So here we have 128.7. Now what we need to do is find the reference angle. Well, I know in quadrants 1 and 2 that this right here is 180 degrees, right? Because it goes 0, 90, 180. Okay, so I have stopped at 128.7. So how much further do I have to go to get to 180? Well, it's just 180 minus 128.7. And what is that going to give us? 52.3? No, 51.3? 51.3 degrees. And there you go. All right, so we have used trig, right, knowing where an angle lies in which quadrant, and a trig ratio to find all 6 trig ratios, the reference angle, and the measure of the angle in standard position. All right, that's going to be all for this video. If you have any questions, please leave them in the comments, and we'll see you all in the next video.